It's space weather! Looking at the sun on 193 angstroms. We've got no sunspots. And we've got an equatorial coronal hole rotating into the Earth-facing region. We are awaiting a magnetic connection with that coronal hole. And when we get one, it could be quite an event because there is an imminent crossing of the heliospheric current sheet, probably in the next 24 to 36 hours. We'll tell you all about it. And taking a look at the magnetic field lines here at 171 angstroms, we can see the area of the coronal hole right here. And nothing else too exciting going on there. Looking at the real-time solar wind, we've got a very positive BZ angle coming in right now. And quite a bit of energy in the BT there. You can see the black line at the top pane. Also, phi angle shifting. So no magnetic connection yet with that coronal hole. Solar wind density looks like it's all the way down to 3.62 protons per cubic centimeter, and we've had a small uptick in the solar wind speed due to a coronal hole wind stream there, 398 kilometers per second. Next, let's look at spaceweathernews.com for some more data. We see no spikes in the X-ray flare there, no X-ray flares, flatlined X-ray flux. Looks like we got some missing data on the Discover and the ACE once again. Now, we see the magnetometers getting pretty jumbled up there at the bottom of the range. We are going to have some big spikes and perturbations in that magnetometer when we cross the heliospheric current sheet, and we will show you what we're talking about momentarily. KP index has settled down from 3 to 2. Here's your Cygnets forecast. And I would have you note this portion which is showing the magnetic field flux. You can see IMF polarity. The positive is red, the negative is blue. And this white line here is the heliospheric current sheet. And the Earth is about to cross that, and it's going to create some extreme magnetometer fluctuations, including large dips and large spikes, most likely, as it usually does. Here we see the electron flux has dropped off, as it usually does, although the coronal hole wind stream is pretty weak. So this electron flux will come back up very shortly. It's probably on its way back up already. Looks like very minimal charging hazards in the ionosphere, and the F2 layer is looking extremely discharged. I mean, see this area here where the sun's located. We're only up to 8 megahertz in that region. So, very discharged ionosphere layer right now. That will probably charge up throughout the day. And there's your aurora forecasts. Quite weak auroras to go with the quite weak coronal hole wind stream. Next, we'll look at the Gong 2, so we can show you what we're talking about the heliospheric current sheet, which is going to play havoc with the magnetometer. Alright, so here you see your two different interplanetary magnetic field polarities. And let me just advance it to the last frame here. Now you can see this orange line going from the Earth to the corona. When this line gets to this area, it's going to suddenly jump across, changing the polarity. And we will see that with the GOES magnetometer. When we see sudden perturbations in that, that's an indication that, well, first of all, if we get a big spike in it, we could we could have a connection down both sides. That does happen. We saw stereo B do that when it crossed this same current sheet. But more likely, what you'll get is you'll get a connection like this, and then it'll just suddenly snap across to the other side, or you'll have this instead. So we're awaiting that to happen. Keep in mind this data on the Gong 2 is 1 hour and 44 minutes behind. We'll let that play through again, just so you see what's going on with it. I don't predict the connection with this area to be too powerful, because you notice at the end, at the end of those lines, down in this area, they're like bundled up there. When you see areas like this, where there's a bulge in the lines and they're very straight, that's a more powerful connection. So the real question is, will the connection go all the way like this, or will it just kind of get to this area? I think it's probably going to be choice B, but the magnetometer will give us the information. We've had an uptick in earthquakes past 24 hours here, really the past 48 hours. So you got a 5.1 in the Mid-Atlantic Ridge, 5.4 in Indonesia, 5.1 in Indonesia. Those are only 4 minutes apart. 4.3 in Russia at depth. So that area, I mean, that area is pretty much on alert anyway all the time. What else do we have? Norfolk Island. Looks like down by New Zealand area. Papua New Guinea gets a 4.5. 4.2 in Mexico. 4.7 in Burma. 4.8 in the Norwegian Sea. That's a pretty rare one. Looks like it's right on the plate boundary there. And if we can zoom in, there we go. North of Svalbard Island. Also a 4.5 in Greece. Let's see, a very deep quake in Bolivia at a 4.4 magnitude. So they should be on alert for a 5 magnitude quake, as that one's 302 kilometers deep. No other quakes of note. Check volcanodiscovery.com. What do we got today? Volcanoes I may be able to or may not be able to pronounce. Shivaluch, producing a 20,000 foot altitude ash plume. Kuchino-Arabu Jima in the Ryukyu Islands. The Ryukyu Islands. Okay, great. Volcanic ash cloud unknown. All right, well, that's helpful. Popocatépetl producing a 21,000 foot ash plume, and Reventador ongoing volcanic ash emissions. Also Karimsky. Next, we'll look at the magnetosphere movies. Here's the velocity. There's the density. You can see the plasma is actually quite dense out at the leading edge of the bow shock there. And finally, the pressure. This is all looking pretty normal. Just one thing to remember is that the angle of attack of this is going to change with the crossing of the heliospheric current sheet. So the current sheet right now is down here, and When it makes it up here, I'm going to change that angle of attack a little bit, and it will be reflected when it happens. Here are the geospace ground-based magnetic perturbations here at the poles. We've got quite a bit of magnetic field coming out of the South Pole there. And let's look at the globe view. And there you can see the effects of that over the globe. Quite a bit of magnetic spillover. That crossing going on over Africa there, we don't normally see that. That's a new one. So some significant magnetic perturbations there. We'll let it play through one more time because there's a lot of data. Thanks to the University of Michigan, Geospace Model V1.5. All right, we got a ton of tabs open, so we're going to do some quick weather stuff real quick. There you go. There's the U.S. AccuWeather Doppler radar. There's the AccuWeather water vapor map. We got some kind of an atmospheric river kind of a situation going on over California, Nevada, Idaho, Utah, etc. And here's a little higher res view of that from the NASA GOES water vapor satellite. Check it out. Here's your atmospheric river. Moving on. We've had a small cosmic ray uptick. Let's show you some data. First at the Athens, Greece cosmic ray monitor. See a little spike there recently. Here's Mexico City. We see a spike in that monitor also. Here's a Moscow neutron monitor that also agrees. Oulu, Finland also agrees, a small uptick in cosmic ray flux, although tighter range at Oulu. Antarctica had a large spike yesterday at the DOMC monitor, which is the largest since December 22nd picked up there. And DOMB also has a spike in the past 24 hours, so small uptick in cosmic ray flux. Moving on. Next, we got a delightful article here for all you people who are going to freak out about the CERN, the Large Hadron Collider, because you don't understand the physics. Check it out on extremetech.com. CERN reveals plans for particle collider 4 times larger than the LHC. Oh yeah, they're going to open up a black hole. It's going to suck the whole universe inside, people. Just kidding. By the way, the CERN's shut down for the next 2 years. And yeah, I'm not sure what the plans are for this, but it's much bigger. So by the time this thing is built, you dudes can really freak out. It looks like it's, oh geez, it could be 2040 or 2050 before the instrument's up and running. Oh my gosh. We are scared. Really, really scared. Keep in mind, these things all happen inside massive magnetic fields, folks, which is why they have no effect on things like the sun. So, anyway, please don't comment and tell us that the LHC is causing solar flares because it's shut down. Cheers. Let's see what's happening at Universe Today. What's happening at universetoday.com. Nothing too exciting. Although, if you were watching yesterday, we were excited about the fact that China's moon lander sprouted plants, cotton seeds that is, on the moon. We'll leave links. Here's another article. This is phys.org from Kiel University. These folks are playing with some plasma, and they're studying the way energetic plasma ions react when hitting a nanostructured solid. Another interesting article. Basically, the moral of the story is Space dust is nothing like non-ionized Earth dust. Here's another phys.org article. I'm not going to spend too much time on this, but apparently the Ice Age climate caused sediment scouring 180 in Gulf of Mexico, whatever that means. And yeah, they're talking about the most recent Ice Age, which was 2.6 million years ago. All right, we'll leave links to the article. I don't know what they're talking about 2.6 million years ago for the last Ice Age, but whatever. We don't care. Another phys.org article. Rife with artist renditions, researchers discover a black hole in our galaxy spinning rapidly around itself. Okay. I think it's just another idea of not understanding cosmology. We think these things operate the same way that the sun does, you know, made of a gaseous plasma. So yeah, anyway, links to that article also. Now we've got an interesting one here. Fast high-energy gamma-ray flare detected from the blazar BL Lacerte. So there's some transients from that. And if you want to know more, read the article. But check this out. You can follow this blazar yourself. Just head to this site here, which studies transients with the Burst Alert Telescope and the Swift. Just go up here, say Find on Page. Type in Lacerte. And there it is. Click on the link. And there you can see Lacerte's transients. Here is 2019. And there have been some transients, actually. So we'll leave links to all that. Finally, let's take a look at the sun at 304 angstroms. You got a towering filament over there in the northwest. And yeah, I think it's already fallen back down into the corona. Thanks for tuning in. Thanks for the plug, David Devine. We're almost to 800 subscribers. Please don't forget to like and subscribe the video. And if you've got ideas for our 800 subscriber special, please leave it in the comments. Got lots of filaments on the entire western limb of the sun there. And on the southeastern limb. Quite a lot of filaments around the board there. So, thanks again for watching. Remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun anyway. Use the proper filters or telescopes. And don't drive.